Hello, this is Domenico with Easynomics, and we're going to look at elasticity, a predominantly elastic demand curve, and what happens with total revenue as we raise and lower price. In the previous video, we looked at an inelastic demand curve, and we saw that there's a direct relationship between price and total revenue, and that is the opposite is true for an elastic demand curve. So we have a fairly horizontal demand curve here. We're going to be looking at the market for Coca-Cola. And since Coke has many substitutes for consumers to switch over to, any change in their price will lead to a dramatic increase or decrease in the quantity of consumption. So just for a review, you want to remember that PED, price elasticity of demand, is equal to the percent change in quantity demanded of a good divided by its percent change in price. And we want to remember as well, this is very important because in econ we're constantly measuring the percent changes. That percent change is calculated as the final value minus the initial value divided by the initial value times 100. And in the previous videos, we saw that we can get predominantly two outcomes, one that's greater or less than 1. So if PED is less than 1, as we saw in the previous video, that's what we call an inelastic demand curve, where consumers are not really responding to a change in price because perhaps it's a necessity or there is no alternative or substitute for them to switch over to, so they just continue to buy even though the price is being raised against them, and thus total revenue rises. So we know that with PED, when it's an inelastic, as we raise price, total revenue rises, and vice versa. If we were to lower price, total revenue would fall, and that's what we covered in the previous video. In this video, we're going to be looking at an elastic demand curve. So here PED is greater than 1, so it's an elastic demand curve. People can really respond to a change in price. And here we see that when we raise price, total revenue will fall. Any change in price will cause people to switch to an alternative or to a substitute. Perhaps it's not a necessity, it's a luxury. If it's a luxury, people will just stop buying it. And vice versa, if price was to be decreased, total revenue would rise since the good becomes the cheaper substitute. Okay, so this is important to remember that with an inelastic demand curve, as price rises, total revenue rises, price falls, total revenue falls, so there's a direct relationship between the two. And with an elastic demand curve, there's an indirect relationship. As price goes up, total revenue falls, or as price falls, total revenue rises. Okay, and that's what we're going to graph and analyze today. So let's just get rid of some of these notes. And illustrate the firm increasing price and then lowering price. So let's start with a price set at P1, right? So we'll start with a high price and the firm lowering it. Okay, so at a price of P1, the quantity demanded is at Q1, so the rectangular area is reflective of their total revenue. All right, so they're producing at point A along their demand curve. And let's say Coke decides to lower their price, becoming cheaper than Pepsi and the other alternative soft drinks. And because it becomes a cheaper substitute by lowering price, they experience a dramatic increase in the quantity of demand. So here we see they lower their price fairly significantly. And that leads to a dramatic increase in the quantity of demand. Okay, so we see that the change in quantity is greater than the decrease in price. Thus, it is elastic. They're at point B. Okay, so some notes that when PED is greater than 1, that means that the percent change in quantity demanded is greater than the percent change in price. And we see that visually here, that the change from Q1 to Q2, the distance between the two is much greater than the decrease or the distance between P1 and P2. Thus, we would expect that as the price decreases from P1 to P2, the total revenue should be increasing. Okay? So let's label some areas to help us discuss total revenue. So here we have A, B, and C. So at a price of P1, right, total revenue, call that total revenue 1, was equal to, obviously, P1 times Q1, which is thus equal to areas A plus B. And then when they lower price to P2, total revenue 2 equal to P2 times Q2, which is equal to areas B plus C. And we'll notice that area C is greater than area A. So since area C is greater than A, total revenue 2 is greater than total revenue 1. Thus, the firm is making more money by lowering the price, becoming the cheaper substitute. So this was a good move by Coca-Cola in this hypothetical example. Okay, so let's go ahead and analyze this. As can be seen, we're illustrating the market for Coca-Cola in graph A. We're measuring the quantity demanded of Coca-Cola along the x-axis and the price of Coca-Cola on the y-axis. We have a downward sloping demand curve in accordance to the law of demand, labeled D1, which is equal to our marginal benefit. Coke starts at a price of P1, and the quantity demanded is at Q1, which we see at point A. We should note that the total revenue of P1 times Q1 is equal to areas A plus B. Coke then decides to lower price from P1 to P2. As they lower price, the quantity demanded increases from Q1 to Q2. And we notice that the percent change in quantity demanded is greater than the percent change in price. Thus, in theory, as they lower price, their total revenue should be increasing. So at a price of P2, total revenue being P2 times Q2 is equal to areas B plus C. And we notice that area C is greater than area A. Thus, total revenue 2 is greater than total revenue 1. Thus, the firm has increased total revenue by lowering price. Okay? Now, the same thing can be said if the firm was to start at P2 and increase price to P1. So in that case, let's illustrate the same concept, but raising price and analyzing it. So here we're going to start at a price of P2, and we're going to increase price from P2 to P1. At a price of P2, total revenue, let me get rid of that. At a price of P2, total revenue, we'll call it total revenue 1, is equal to P2 times Q2, which is equal to areas B plus C. Okay? And then they raise price to P1, and then here total revenue 2 would be equal to P1 times Q1, which is equal to areas A plus B. So thus, since area A is greater than C, it should be that total revenue 2 is greater than total revenue 1. Oops, A being greater than, I'm sorry, let me take that back, sorry. Area C is greater than A. Sorry for that. Since area C is greater than area A, total revenue 1 was greater than total revenue 2. So thus, as the firm raises price, total revenue is falling. So that was a bad idea to raise price from P2 to P1 because they had much more total revenue with areas B and C than with areas A and B. So the firm is losing money. So the rise in price leads to a fall in total revenue. Okay, so let's go ahead and illustrate or analyze that. So as can be seen, we have a graph A illustrating the market for Coca-Cola. We're measuring the quantity demanded for Coca-Cola on the x-axis In the price of Coca-Cola on the y-axis, we have a downward sloping demand curve in accordance to the law of demand, labeled D1, which is equal to our marginal benefit. And we're going to start at the firm pricing at P2, and at a price of P2, the quantity demanded is at Q2 at point B, and total revenue is equal to B plus C. All right, so the price of P2, total revenue is equal to P2 times Q2, which is equal to areas B plus C. Then the firm decides to raise price from P2 to P1. Quantity demand then falls from Q2 to Q1. It's a movement along the demand curve from point B to A. And at a price of P1, total revenue 2 is equal to P1 times Q1, which is equal to areas A plus B. And since area C is greater than area A, right, this area here, this rectangle is greater than area A, the original total revenue was greater than the second total revenue. Thus, the firm is losing money. As they raise price, total revenue fell. As they raised price from P2 to P1, total revenue decreased. Okay, and that's it. That's what we would be illustrating to illustrate the relationship between price and total revenue along an elastic demand curve. In the previous video, we looked at price and total revenue on a inelastic demand curve. If you have any questions, feel free to comment, and don't forget to subscribe and like. Thanks so much.